So previously we solved linear equations. So now we're going to be solving linear inequalities. If we replace the equal sign with an inequality sign in an equation, the equation then becomes an inequality. So for linear inequalities, it's going to have one of these setups, either ax plus b less than 0, ax plus b less than or equal to 0, greater than 0, greater than or equal to 0. So it's just written like this. Just so you can see that it's linear. A and B are just numbers, and the x has an exponent of 1, making it a linear inequality. So to do this, what we're going to be doing is finding the set of numbers that makes the inequality true, and these set of numbers is going to be called the solution set for the inequality. So we're not going to be getting an answer like x equals 3. It's going to be something like x is greater than 3. It's going to be a whole set of numbers. So we're going to be solving these the same way that we solved linear equations, except when we multiply or divide by a negative number, the direction of the inequality symbol is reversed. So multiplying or dividing by a negative on both sides of the inequality is going to flip the inequality symbol. Other than that, same exact way as an equation. So let's do these examples. So solve, and we're going to graph it on the number line also. So 5x plus 11 less than or equal to 26. So we're trying to figure out the values for x that'll keep this being true. So we're going to subtract 11 on both sides, just like we did with equations. So we get 5x less than or equal to 15. Divide both sides by 5. And we get x less than or equal to 3, and that would be our answer. So everything less than or equal to 3 that we plug in for x will make that inequality be a true statement. So the way that we're going to graph this on the number line, we're going to graph it, we're going to go to 3, so here's 3. Since it is or equal to, I'm putting a closed circle. I am filling it in on 3. And it's everything less than it. So I am filling it in like this with an arrow to the left. So it's going to keep on going to the left. Okay, for the next one, we have 3 minus 2x less than or equal to 11. We subtract 3 from both sides, and we get negative 2x less than or equal to 8. And then we're going to divide both sides by negative 2. And we're going to get x less than or equal to negative, oops. So we just divided by a negative, right? So we divided by a negative. So this means we need to flip the inequality or reverse the inequality symbol. So instead of less than or equal to, it becomes greater than or equal to. So it's easy to miss, so just kind of remind yourself that you have to be careful. So we get x is greater than or equal to negative 4 because we flipped it from less than or equal to greater than or equal to, and then we're done. Okay, so graphing this on the number line, we go over to negative 4. And we do everything greater than it because it's everything to the right of it. And we fill it in completely because the circle on negative 4 because it was or equal to. Next one, negative 2x minus 4 greater than x plus 5. So we want to get all of the x's on one side. Something that we could actually do here is put some forethought into it. If we get the x's on the left side, we would have to subtract this x, right? Oops, we'd have to, there we go, subtract that x. We would get negative 3x on the left. That's going to tell you that we're going to have to divide by a negative 3 later on, which is going to have to reverse the inequality. For this one, just for the sake of doing it a little bit differently, I'm going to get the variables on the right-hand side. which means I'm going to add 2x to both sides. So we're going to get negative 4 greater than 3x plus 5 from the x plus 2x. Then I'm going to subtract 5 on both sides and get negative 9 greater than 3x. Divide both sides by a positive 3, and we get negative 3 greater than x. You do not want to leave your answer like this. You want to have x on the other side, on the left-hand side. So it'd be x is less than negative 3. So it's kind of up to you. You can put forethought into it and make sure your x's are positive. Then you're never going to have to flip the inequality. So either way, whatever if you think is easier for you. So everything less than negative 3. So here's negative 3. So this time it is not or equal to, it's just less than. So I am not putting an or equal, I'm not closing the circle on negative 3, I'm leaving it as an open circle. So it's everything less than negative 3. So put an arrow to the left and it would look like that. Do several more here, make them more complicated. So for D, we have 5 times x minus 3 minus 7x greater than or equal to 4 times x minus 3 plus 9. So we need to simplify both sides of that inequality first, independently, before we do anything. So we have to distribute the 5 on the left. It becomes 5x. It becomes 5x minus 15. And then minus that 7x greater than or equal to, we have to distribute the 4 on the right, 4x minus 12 plus the 9. We have to combine like terms on both sides separate or independently now. So 5x minus 7x is going to be negative 2x. And negative 12 plus 9 is negative 3. So now we can get all the variables on one side, constants on the other. I'll get the variables on the left this time. If you want to put them on the right, that's fine. I'm going to subtract 4x. And in one step here, I'm going to add this 15 to the other side too. If you have to do it in 2 steps, that's fine. So it's going to be negative 2 minus 4 is negative 6x greater than or equal to negative 3 plus 15 is going to be 12. So now dividing both sides by negative 6, as soon as you're doing this, dividing or multiplying both sides by a negative, we know we have to reverse the inequality. Flip the inequality sign. So instead of greater than, it's going to be x is less than or equal to 12 over negative 6 is negative 2. And that's our final answer. So there's other ways that we can write the answer for these. There is something called interval notation, which we'll get to also. But leaving it like this for now is fine. So we go over to negative 2. We fill it in because there's the or equal to. And it's everything less than it, so everything to the left of it. So we draw an arrow to the left. Okay, next one, couple more here. Oops. Okay, we have fractions. So we have 3/4 times x minus 6 less than 2/3 times 5x plus 1. So we could distribute those fractions, but then we would be working with fractions, which is fine. If you want to do that, that's okay. Just remember the other way to do this is to multiply both sides of the inequality, in this case, by the LCD. The least common denominator of every fraction here, that's the least common multiple of 4 and 3, which is 12. So we're going to multiply both sides by 12. And the whole reason for doing this is because this is going to cancel off all of the fractions. So I'm going to multiply that by 12 and this by 12. So this is going to be 12 times 3/4. So you can do 12 times 3, which is 36, divided by 4, which is 9. Or you can do 12 divided by 4, which is 3, times the 3, which is 9. So hopefully that wasn't too fast. Either way, 12 times 3/4 is 9. For the right-hand side, I'm going to do 2/3 times 12. So 2 times 12 is 24, divided by 3 is 8. Okay, and now we just solve this like we normally have been doing. So distribute the 9, we get 9x minus 54 is less than, distribute the 8, 40x plus 8. So I'm going to get all of the variables on, I'll get the variables on the right side this time. It doesn't matter at all. I'm just going to do it differently. So subtract 9x to the right, which means we have to get this 8 to the left by subtracting it. Okay, so this is going to be negative 54 minus 8 is negative 62, less than 40 minus 9, 31x. So we're going to divide both sides by 31. Negative 62 divided by 31, it's going to give us a nice clean negative 2. So that means negative 2 less than x. We don't want it like that. We want x first. X greater than negative 2. So we go over to negative 2. We put an open circle because it's not or equal to. Everything greater than it means everything to the right. Okay, next one, so we have more fractions. So we want to be thinking LCD again. So this is going to be the LCD, or the least common multiple, of 4, 3, and 4, which once again, just like the last one, is 12. So we're going to multiply both sides of this inequality by 12. So what this means is we're multiplying essentially every single term here by 12. So I'm going to simplify this. 12 divided by 4, so the left-hand side, 12 over 4 is 3. So this 3 right here came from 12 over 4. And then 12 over 3 on the right-hand side, we have to distribute that 12 to both terms. 12 over 3 is 4. So we get 4 times x minus 2 plus 12 times 1/4 is 12 divided by 4, which is going to be 3. Okay, and now we just solve it like we've been doing again. So on the left-hand side, distribute the 3, we get 3x plus 9. The right-hand side, distribute the 4, we get 4x minus 8. So we need to combine like terms on the right. Negative 8 plus 3 is negative 5. And I'm going to get the variables on the left. You can put them on the right if you want. And I'm also just going to subtract 9 to get it to the right at the same time. So 3x minus 4x is negative 1x. Negative 5 minus 9 is negative 14. So we need to do one more thing. We need to either divide or multiply both sides by negative 1. I'm just going to think of this as, I guess, dividing by negative 1. It doesn't matter. Same thing. So since we divided by a negative, we need to reverse the inequality. So this is going to be x is less than or equal to positive 14. So on the number line here, I'm just going to put a 0 and 5, 10, 15. So maybe 14 would be right about here. Just going to erase this 15. So we're going to fill in the circle because it's or equal to. And it's everything less than it, so to the left. And that's our graph for it. Next one for G, we'll see a couple different cases here in the last couple. So we have 2 times x plus 4 greater than 2x plus 3. So distributing the 2, gives us 2x plus 8 greater than 2x plus 3. So I'm going to subtract this 2x. But what happens is that cancels on both sides. So what we get is 8 is greater than 3. So just like linear equations, the same type of thing just happened here. If the variables cancel, and it results in a true statement, then that means no matter what value of x you plug in, it's always going to be true. So that means there will be infinitely many solutions. I'll write this as the solution set is the all real numbers. So it's going to be all real numbers, meaning it's going to be everything. So it's going to be from negative infinity to positive infinity. If you really wanted to write it how we have been writing it, you could write it like this. It kind of looks a little messy. Negative infinity to positive infinity. So that's like saying x is greater than negative infinity. Oh, sorry, not what I meant. X is between negative infinity and positive infinity. I'm actually not even going to write like this because when we get into interval notation, there's going to be a better way that looks a little bit better. So for now, what we can say is that there's just the solution set is all real numbers. So what this would look like if we graphed it on the number line, what we would do is we would just draw a line and draw arrows going both ways. So if we go back up to the top to that inequality, no matter what we plugged in here, the left-hand side is always going to be greater than the right-hand side. Okay, so let's see what happens for this last one, x plus 7 less than or equal to x minus 2. So I'm going to try to subtract x on both sides, and they cancel. So this time we're left with 7 is less than or equal to negative 2, which we know is not true. So this time, if the variables cancel, which they did again, if variables cancel and it results in a false statement, so it's false because 7 is not less than or equal to negative 2, then there are no solutions. So no matter what we plug into this inequality, nothing will make this one true. It'll always be false. So we could say that this would be the empty set if you wanted to say it like that. Okay, so that is it for section 2.8.